Good morning, everyone. If you've taken a geometry class before, you've likely come across, or you're likely familiar with the fact that for any triangle, if we were to look at the measures of all of their angles, and I'll call this angle A, and this angle B, and this angle C, if we were to look at the measures of all of those angles, right, the measure of angle A plus the measure of angle B, the sum of all of them, right, plus the measure of angle C, is always going to equal to 180 degrees. And so I think this is something that's often presented as a fact, right, which it is, but to me, when I hear something like this, my first instinct is to say, well, why? Right? And in fairness, this is something that we can, for the most part, observe to be true, right? We could take this triangle and we could break out our protractors and we could measure all of the angles and add them up and see that they'll equal 180 degrees, at least closely if we measure it really accurately. And maybe that's enough to satisfy you. But part of me also wonders, at that point at least, well, what if our measurements were just the teeniest bit off? Right? And rather than all of them being 180 degrees, what if one was like 179.999, right? It's so close to 180 degrees that we can't even really detect it with a protractor, but it seems like it's close. Or what if one was on the other side, just slightly bigger than 180, maybe 180.0000001 degrees? Like, how do we know that all of these are precisely 180? Right? Because we're not just saying, yeah, they're about 180 or they're pretty close to 180. No, they all add up to exactly 180 degrees. How can we possibly know that? And that's what we're going to get into today. Why do the angles of a triangle always add up to 180 degrees? And now there's a couple things that we need to be familiar with before we can demonstrate that this is always going to be true. And those have to do with parallel lines. There's two things that we have to know about parallel lines in order to demonstrate this to be true. And the first is that if we have a line and we look at some other point that does not go through our line, so say this point here, right? And it could be any point, but it does not run through the line that we already have. There is at most one unique line that will run through this one and also be parallel to the one that we already have, right? So there is only one way we can draw this green dashed line through this point that is parallel to the black line, right? Because at any other angle, right, at any other angle that I would draw this, it would at some point intersect, which means, well, these are not actually parallel. We're going to rely on the uniqueness of this line. The second thing that we want to know about parallel lines is that if we were to take two parallel lines and we were to draw what is called a transversal, a line that runs through both of them, then the angles that are on opposite sides of the line and inside of these two parallel lines, in between these two parallel lines, are going to be equivalent. And these are known as alternate interior angles. And these are of equivalent measure, are equivalent in measure. And so we're going to need to rely on both of these two facts here in order to demonstrate that triangles will always add up to 180 degrees. And so this first one says that the parallel line through a point is unique, and the second one says that alternate interior angles are equivalent, right? And we'll take both of these two together. And so let's apply this to a triangle now. And let's say this is our triangle here, right? And let's say that we have a few different angles. Maybe we'll label this one A, maybe we'll label this one B, maybe we'll label this one C. And our goal ultimately is to answer the question why A plus B plus C is equal to 180, right? So our goal here is to show that A plus B plus C adds up to 180. And so what we're going to do is we're going to take advantage of that idea with the parallel lines. Let's take the base of the triangle to start. And let's draw a line straight through that base. And then let's look also at the tip of this triangle. So we've got a line through the base and we've got a point at the tip of this triangle. And based on what we were assuming about parallel lines, we know that there also has to be a line through that point, and that line has to be unique if it's going to be parallel to our previous line. And so we have two lines here that are parallel, and these are the only possible ways we can draw these two lines. And so we've taken advantage of fact one already to construct this green line here, and to know for certain that there's only one way in which we can draw that. Next, I'd like to take a look at this side AB, which I'll highlight in blue here. And let's imagine that along that line, we drew a line through each of the two green parallel lines. Now, this blue line here is a transverse between the two green lines, right? It intersects both of those two that are parallel. And because of alternate interior angles, right? So by alternate interior angles, we can say that this angle here is going to have the same measure as angle A. And then we can do something similar with the other side of our triangle. And this one I'll draw in red. But if we draw a transversal along the side length BC of our triangle, we can also say, using alternate interior angles, that this angle here is the opposite one of C, and so it also has to have the same measure as C. And so now we've been able to take advantage of both of the two facts that we previously discussed. We were able to find that this line here, find and construct this line here, and know that there is only one way that we can do so. And we were able to use alternate interior angles to determine that this angle has measure A and this angle has measure C. And so now let's take a little bit of a closer look at this region here, because this is going to tell us all that we need to know from now on in order to figure out that these equal to 180. So we have this green line. You might be familiar with this in terms of a discussion on supplementary angles. Right, when some number of angles intersect a line, as A, B, and C have with this green line here, right, they have to add to 180 degrees. And now at this point, you might be able to see where we're going with this, because since A, B, and C are supplementary angles, since A, B, and C form supplementary angles, their sum has to be 180. So the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees, right? And that A, B, and C are the same A, B, and C that was in our triangle here, right? The same A, B, and C of our triangle. And so we have that A plus B plus C has to equal 180, and thus the sum of the angles of a triangle has to add up to 180 degrees. And so this is more than just something that we have observed through measurement to be pretty close to the truth. We've actually logically deduced that this is something that has to be true all the time, right? The angles always have to add up to 180 degrees. That's more than just an observation through measurement, but actually something that we were able to determine for certain. And that's pretty cool. I hope you found this video interesting. Thank you for submitting the question. If you do have any other questions, please don't hesitate to post them in the comments below. Thank you for watching and have a great rest of your day.